Hi and welcome to today's class. So today is the 23rd of April and this is the second probability lesson. So if you haven't already watched the first video, please make sure that you do so first. Here we're going to talk about the fundamental principle of counting. We're going to look at events and outcomes and sample spaces. So just to go back over the list that we wanted to review, in the last video we had probability scales, we calculated some probabilities and we looked at multiple events. So now we're going to look at listing outcomes using two-way tables, and the last two pieces we're going to do in the video for tomorrow's class. So listing outcomes, when we have multiple events, we can use a sample space or two-way table to list all the possible outcomes. So imagine I ask you about throwing a dice. So when we throw a dice, the numbers could be 1, 2, 3, 4, 5, or 6. So each of these are called a result or an outcome. The actual throwing of the dice is called an event. So in probability, there are events, and each event will have multiple outcomes, and we will be asked about the probability of each of the outcomes. So you might be asked, what's the probability of throwing a 2? What's the probability of throwing a 5? And so on. So if I asked you, what are the outcomes when a coin is tossed? When I toss a coin, what are our outcomes? So they are heads and tails. So imagine if we then combine the two events. Imagine if we said, well, let's roll the dice and let's toss the coin. So what are all the possible outcomes when we do that? So if we think, well, we could get heads on the coin or tails on the coin, and we could get a 1, 2, 3, 4, 5, and 6 on the dice. For ease, I'm going to use H to stand for heads and T to stand for tails. So these are all the outcomes. This looks a bit overwhelming, but what that means is I could get heads and a 1 on the dice, heads and a 2 on the dice, heads and 3 on the dice, and so on. Or I could get tails with a 1, tails with a 2, tails with a 3, and all the way up to tails with a 6. So if they're all our outcomes, how many outcomes are there? So if you count them up, you'll find that actually we have 12 outcomes. So listing all those outcomes, it's not a very nice way to work. It's quite tedious. Like surely there is a nicer way to do that. But what if I said to you, well, how if we had 2 outcomes for the coin and 6 outcomes for a dice, how might we use those 2 numbers to get to 12? Any ideas? So this leads us to the fundamental principle of counting. So there are 12 outcomes to throw a dice and toss a coin, and we had 6 outcomes for a dice, 2 outcomes for a coin, so hopefully you figured it out. How do we get to 12? It is simply multiplying. So what the fundamental principle of counting means is that we multiply the number of outcomes to get the total number of outcomes for the 2 events. So there are a total of 12 outcomes. And that might seem a bit mad because you might say, well, surely if there's 6 on a dice and 2 on a coin, then we would just add them. But let's look at a better way to illustrate this. Here's a table. So on the table, I have the outcomes of a coin on the left and the outcomes of the dice around the top, across the top. So if you see, because the way we have this table, it's 2 down and 6 across, so the number of outcomes inside of it will be 2 by 6, and that's where that multiplication comes from. So when we want to figure out the total number of outcomes of 2 or more events, we simply multiply the number of events. So here we have 6 columns by 2 rows and we get 12 outcomes. So let's look at an exam style question. A shop sells chicken wraps. There are 4 different sauces and 3 different types of chicken as shown in the table. So we could have barbecue sauce, mayonnaise, hot sauce, sweet chili, and the types of chicken, there is plain, fried, or tikka. Margaret picks one of the 4 sauces at random. Write the probability that she picks hot sauce. So we did something like this in Monday's class. So there is one option of hot sauce out of 4 possible options. So the probability that she picks hot sauce is 1 in 4. Remember we said that the probability is also the same as the fraction. So for example, what fraction of the sauces are hot sauce and that will give me the same answer. Margaret picks one sauce and one type of chicken. Fill in the space below to show 3 different combinations that Margaret could pick. One is already done. So she could have hot sauce and plain chicken, and maybe she could have barbecue and fried chicken, and maybe she could have sweet chili and tikka. That doesn't sound very pleasant, but it is an option. So how many different possible combinations are there that Margaret could pick? So this is a fundamental principle of counting. So fundamental principle of counting question. There are 4 outcomes for sauces, 3 outcomes for chicken, and the fundamental principle of counting tells us to get the total number of outcomes, we multiply it. So this gives us 12 different combinations. So let's look at using a two-way table to list all the possible outcomes. I'm going to give you an example of rolling a dice and tossing a coin. So what is the probability of getting heads and a 3 when we roll the dice and toss the coin? Now remember, probability, the number of ways it happens, the total number of outcomes. So when we talk about a two-way table, it's setting up a table where it has one set of outcomes along the left hand side and another across the top. It doesn't matter which. I've just moved this to having 1 to 6 at the bottom and heads and tails across the top. So what's the probability of getting heads and a 3 when we roll the dice and toss the coin? So there's only one way that that can happen, and we can see it there, and that's out of, if you count all that up, 12 outcomes. So the answer is 1 in 12. So what is the probability of getting a tails and an even number when we roll a dice and toss a coin? So again, we go back to our sample space. So this is our two-way table that we're using, and we want to figure out tails and an even number. So that could be tails and a 2, tails and a 4, tails and a 6. Remember, even is a number that can be divided by 2. Odd numbers are then the opposite. So even, that's 2, 4, 6, 8. And any number that ends in 0, 2, 4, 6, and 8. Odd are then the other numbers that are left. So there is a tail and a 2, a tail and a 4, a tail and a 6. So that is how many ways can it happen? So there are 3 ways that can happen out of a total of 12. But when we looked on Monday at calculating probabilities, I said to you that that won't get you all your marks, because it's important that when you write your fraction that you write it in its simplest form. So you can use your calculator to help, or you can ask yourself the question, what number divides into the top and the bottom of that fraction? So into the numerator and into the denominator. So here we can divide both the numerator, the top, and the bottom, the denominator, by 3, and we get a final answer of 1 over 4. So let's take another look at a sample space, and this time I'm going to toss 2 dice, and then I'm going to add my numbers to get a final score. So imagine this like any board game that you might have. If you play Monopoly, you tend to play that with 2 dice. Any other game where you might play with 2 dice. So we're going to set up our table like this. The first dice is 1 to 6, and the second dice is 1 to 6. And in the table, we're again going to fill it in. Remember, we're adding. So if I get 1 on the first dice and 1 on the second dice, then that will add and give me 2. If I get 1 on the first dice and 2 on the second dice, I get 3. 1 on the first dice and 3 on the second dice, and I get 4. Let's take this little square here. So that is, I got a 5 on my first dice and a 4 on my second dice, so that's a total of 9. So this is what it looks like. I'll get rid of all my drawings. When we have all that filled in, we are rolling the 2 dice and adding our numbers. The smallest number we get is 2, because each dice has a 1, so the smallest possible number we can get is 2. And then the biggest number we can get is 6 plus 6, which is 12. What number appears the most? So actually, if you take a look at our table, there's some lovely patterns in here. So you'll see that we have 7, 7, 7, 7, 7, 7. So 7 is probably the one that appears the most. So then we have a line of 8s, we have a line of 9s, we have a line of 10s, and so on. And the same is true over here. So we have 3s, we have 4s, we have a line of 5s, and we have a line of 6. So you can see these lovely lines appearing, this lovely pattern. So what number appears the most? And that is 7. And the reason that the 7 appears the most is because it has the most ways to get to 7. Because 7 could be got by 6 plus 1, or 5 and 2, or 3 plus 4. Unlike, say, 2, the only way to get 2 is to add 1 and 1. There's no other way it can happen. So the 7 is the number that appears the most. What number appears the least? What numbers, plural, because there's 2. The 2 that appear the least is the number 2 and the number 6. Or sorry, the number 12. So then, taking this table, let's talk about some probabilities. What's the probability of scoring a 7? So how many 7s are there? So there's 1, 2, 3, 4, 5, 6 out of a total number of outcomes of 36. Now I did not count them. I said there was 6 across the top, 6 down the page, and that was 6 by 6. We can use our fundamental principle of counting there to help us. So if I roll a dice with 6 outcomes and I roll a dice with 6 outcomes, that's 2 dice with 6 outcomes. 6 by 6 is 36. Now, 6 over 36 is not going to get you full marks because that fraction is not as simple as possible. We'll need to see what divides into the top and the bottom. So 6 divides into both the top, the numerator, and the bottom, our denominator, and we're left with 1 over 6. So then what's the probability of scoring a 5? So 5. So there's 1, 2, 3, 4. So that will give us a probability of 4 over 36. Again, let's try and simplify that. 4 divides into the top and the bottom, so into the numerator on top and the denominator on the bottom. And when we divide 4 into the top and the bottom, we get 1 in 9. What is the probability of scoring less than 5? So what could I score that would be less than 5? So I could get a 2, I could get a 3, or a 4. So here are all the outcomes that are less than 5. And look where they are on the table. Like, there's a lovely pattern happening. They're all to the left of that line of 5s. So there are 1, 2, 3, 4, 5, 6 outcomes. So that gives me 6 out of 36. And again, I'm going to simplify this. 6 divides into the top and the bottom. So when I do that, we get 1 in 6. So let's take a look at an exam style question. In a game, Mia flips a coin and rolls a 6-sided die. List all the possible outcomes in the table. 3 are already filled in for you. So heads and 1, heads and 2. We could get heads and 3, heads and 4, heads and 5, heads and 6. This will be tails and a 1, tails and 2, tails and 3, tails and 4 is already filled in, tails and 5, tails and 6. Write down the total number of possible outcomes. So we can count them from the table if there's 12, or using the fundamental principle of counting, we had a coin which had 2 outcomes, and so multiply a dice which had 6 outcomes, which gives us 12 outcomes. But like I said, we could have just counted the table. Find the probability that Mia gets a H3. So there's one of those out of my 12 outcomes, so the probability is 1 in 12. Now it says find the probability that Mia gets a tails on the coin and an even number on the dice. So tails, so T and an even number. So that could be tails and a 2, tails and a 4, or tails and a 6. So that is 3 outcomes. Oh, my 4 didn't work, so T and a 4. So that's 3 outcomes out of 12, but I want to simplify that. 3 divides into the top and into the bottom, so that leaves me with a quarter.